All right, the mean value theorem for derivatives. It's a really basic concept. It's just this idea that, and I'll draw a little picture over here. You know, if you got a graph, you got some curve on that graph, and let's say we just were to pick 2 points. Let's pick here, and we'll call that the x value of A, and let's pick like this point over here, and we'll call that the x value of B. We could extend our x-axis here. All right. That would, of course, make this height f of A and this height f of B. All the mean value theorem says is you got these 2 points on the curve. If you were to have a line that went right through these 2 points, well, there'd be a slope to this line, right? And that slope would equal the same way we find slope in algebra 1, right? F of B minus f of A over B minus A. Well, all the mean value theorem says is that somewhere along this curve, there must be at least one point that has a slope that is equal to the slope of this line. And on this one, there's probably 2. There's probably one right around here, and there's probably one right around here. Right? So there's these points where the slope is going to be equal. And so what we would say is if it's equal to that, then there must be some value that we would call C, where the derivative of the function at C would equal that slope. That's it. It's a really simple concept. So there's a couple conditions that need to be met in order for it to work. It says if it's continuous, so it has to be continuous. Notice there was no holes or jumps or anything on this interval. So it has to be continuous on A to B and differential on the open interval. So all that means is continuous from here to here. So this point has to actually exist and this point has to actually exist. But it doesn't have to actually be differential at A or B, just in between, because, well, we're only finding a value of C in between, not at A or at B. And as long as that's true, then there has to be some number C where the derivative, where the slope at that point is equal to the slope between the 2 points. That's it. So here's the conditions. Continuous on the closed interval, differentiable on that interval, and then f of A can't technically be equal to f of B. This is really a special case. If it is equal to each other, then it's a special case called Rolle's theorem, which we're going to go over in the next video. And that's what's going on here. Rolle's theorem. So notice it's really it's pretty much the exact same math. It's just that it's called something different here. So Rolle's theorem is a special case of the means value theorem, and that's when the heights do equal each other. Therefore, you get a slope of 0, and that's what's going on here. And we'll talk about that in the next video, like I said. All right, so let's go to the next page. We got a practice problem here, and here we got another little sketch explaining it, right? That there must be some slope. Well, this doesn't really give us a good idea, but there must be some slope that is equal to the slope between these 2 points. That's all it really says. So find the values of C that satisfy the mean value theorem. Well, just look at the equation that we have here. We need all these parts. You're going to need the derivative. You might want to do that first. You're going to need f of B and f of A. So let's just go to it. Let's first do the derivative. And C is going to end up just being the same thing as what we have as x. A lot of times you won't even write C. You're just going to solve for x. You'll see as I do this. And then your x value is the C value. So maybe just a good idea to say C is your x value. So let's just do f prime of x. And this is supposed to say x squared right here. So this would be 2x plus 2. Okay. Now let's go ahead and find f of A and f of B. This is your A and your B. So f of A would be f of 0, which is 0 squared plus 2 times 0 minus 1. Well, that whole thing just equals -1. All right, let's do f of B. That would be 1 squared plus 2 times 1 minus 1. This is pretty easy to figure out. This is just a 1 and this is -1, so in the middle we just have a 2. So f of B just equals 2. Okay, So now we have all the parts, and now let's just plug it into that formula. So I'm looking at this thing up here. I already found f prime of c. Remember, this is kind of like your c here. You could put a c in there if you want. It doesn't really matter. I like to just keep it as x and just know that when I solve for x, that's the c value. So we got 2x plus 2 equals f of b, we found out that is 2, minus f of a, we found out that is negative 1, over my b, which I know from right here, that's 1 minus 0. Okay, hopefully see I got all of that from here. I found the derivative and I got all the points. All I did is just plug it in. So this on the right would represent the slope between these 2 points. This on the left represents the derivative of the function, which is all slopes. And so all we're doing is we're just finding the point where the tangent slope is equal to the slope between these 2 points. And we just do that by setting them equal. And so you end up with 2x plus 2 equals 2 minus negative 1. That turns into plus. So this is a 3. 1 minus 0 is 1. So this is really just like saying 2x plus 2 equals 3. Subtract 2, you get 2x equals 1. And divide by 2, divide by 2. You get that x equals 1/2. Or, like I said before, c is 1/2. Right? So the answer for this is the c value is 1/2. So you could write c equals 1/2 too. Pretty much how you're usually going to have to write that. I've always got the habit of just using x's instead. It really doesn't matter. You could plug a c in here if you want. Same thing. Okay, let's go to the next problem. Okay, example 2. So again, we got a function, and we got the a and the b value here. Remember that we're just trying to find, this is the basic formula for finding mean value theorem, is f prime of some c value equals f of b minus f of a over b minus a. Sorry, my computer made a noise there. And so we're just going to find all those parts. Let's do the derivative first. That's the easy part. So f prime of, let's just put a c here this time so you know that we can do that. I'm just going to replace everything with an x with a c. So this would be 3c squared. All right, now let's also go ahead and find f of a and f of b. So f of a would be f of 1, and f of 1 would be 1 cubed plus 1. Well, 1 cubed is just 1, so 1 plus 1 is 2. All right, what about f of b? F of b, well, that would be f of 2, and so that would be 2 cubed plus 1. 2 cubed is 8, 8 plus 1 is 9. So using this guy over here, we can go ahead and just plug in all of our parts, and we could solve. We know that the f prime of c is now 3c squared. We know that the f of b is 9. We know that the f of a is 2. And we know that the b is 2 minus the a is 1. Okay, let's zoom in and just solve this thing. So it's not always going to be nice and pretty like the last one. This one's actually going to be a little nasty, but it's not that big a deal. We get 3c squared equals 9 minus 2 is 7, and 2 minus 1 is just 1. So essentially this is 3c squared equals 7. And we could divide by 3. And so you would get c squared equals 7/3. Square root. And so you end up with the c value equaling the square root of 7/3. Now, usually this is fine. If the problem was a multiple choice, the AP exam may ask you to rationalize it. It's hard to tell whether they would do that or not. So let's just remember how we could do that. This is like saying the square root of 7 over the square root of 3. And you could just multiply top and bottom by square root 3. And so you would end up with the square root of 21 over just 3. And so that's a rationalized version of the answer. I think that Khan usually accepts unrationalized answers, but just in case, you need to know how to do both. Okay, that's fun. All right, last problem here. This one is for you to try. This is a little bit different type of function, but still, I think you could pull it off. Remember, all you're doing, start with this formula. Maybe easy if you just copy this formula down. and then just find all the parts, find the derivative, find these values, set it equal, and solve. Go ahead and give it a try. I'm going to work it out here, and then you should pause the video and then unpause it when you're ready to check your work. Okay, a lot of stuff here. Over here I found the f of a and the f of b. Over here I found the derivative of x, and I end up with 4 over x squared. I did this by rewriting the function. I think this is a really good trick. Hopefully, if you haven't figured this out yet, when you got an x on bottom and you don't have an x on top, it's not quotient rule. You can just rewrite it like this, and then it's a really easy power rule problem. So, I found my f of a, it was 1. Found my f of b, it was 4. So when I plug everything in, I'm going to get a 4 minus 1 on top. I also have a 4 minus 1 on bottom, so this ends up just being a 1. Derivative is 4 over x squared. So in order for this to equal 1, the top just has to equal the bottom. So I went ahead and set them equal, take the square root, and you get plus or minus 2. So in this situation, there's actually two values. There's two values, both positive and negative 2, that meet the same slope. But however, they're not both between 1 and 4, are they? Right? Positive 2 is between 1 and 4, but negative 2 is not. So the correct answer, and again we could just say the c value, is just 2, right? Because we're only looking on this interval from 1 to 4. So just important to notice that. All right, that's it. See you guys in the next video.